Hi everyone, welcome to section 8.1, which deals with simplifying rational expressions. Rational expressions is basically just, a fraction ratio where you have, an expression on the top and something else on the bottom, another expression. See, this is a rational expression. There's so many different kinds, but what we're going to get into is simplifying them. So first of all, before we do that, we need to make sure that we determine when is a rational expression considered undefined. And, a big rule, right, is we cannot divide by zero, right? That's a no-no. We cannot divide a number by zero. So in order to figure out when a rational expression is undefined, we set the denominator equal to zero and then solve the equations if possible. So then basically we ask ourselves, okay, so let's say for A, we have 9y over x. So since you can't divide by 0, x cannot be 0. So that's it. So that's A. It's undefined at A. So undefined at x equals 0. Okay, so then for B, you would set the denominator equal to 0 and then solve, 2b equals -5. So B cannot be 5 over 2, or you would say something like undefined at B equals -5 halves. Okay. And then here, for instance, you have x squared plus 5x plus 6 in the denominator. So you set that equal to 0 and factor. X plus 2, x plus 3 equals 0. Zero product property. So then we would have, if you solve, you would get x equals -2 and then x equals -3. So these are both undefined at these values. Undefined. So some people write undefined at this value, or you just can say x cannot be -2, x cannot be -3. And that's the same idea. Okay, I think we've done enough of these. Let's see here. So then you need to be able to evaluate rational expressions at certain values. So if you have a problem like this where you say evaluate 2x plus 3 over 3x minus 5 for each value, you just plug it in and simplify. So 2 times 0 plus 3 over 3 times 0 minus 5. Your answer would just be 3 over -5 or -3/5. That's A. For x is equal to 2, you would get 2 times 2 plus 3 over 3 times 2 minus 5. So then that becomes 4 plus 3 on the top and 6 minus 5 on the bottom. In other words, 7 over 1, which is just 7. So that's what, the rational expression evaluated at 2 is. Now, the value of the rational expression evaluated at x equals -3, well, you just plug in -3 on the top and then -3 on the bottom. So then you would get -6 plus 3 on the top, -9 minus 5. So then that becomes -3 on the top and -14. In other words, 3 over 14. All right, let's talk about simplifying rational expressions. Okay, so a rational expression is considered simplified if there are no common factors in the numerator and the denominator. So for example, 2 over 3 is simplified because there's no common factors of 2 and 3. 2x over 3x is not simplified because x is a common factor of 2x and 3x. So if you have equivalent fractions property. So let's remember that if you have a fraction and you multiply top and bottom by that, any number, you would still get the same value. So let's say, for instance, here we have -36 over 63. Well, we can see that 36 is equal to 4 times 9, and 63 is 7 times 9. So by equivalent fractions property, you can cancel out the common factor, and that gives you -4 over 7. So then here we have 3 times x times y, 3xy over x times x 18 x squared y squared. So if you divide top and bottom by 3, so let's say, for instance, if I was to rewrite it, this is 3 times 1 times x times y. This is 3 times 6, and then there's x squared, y squared. So you could see clearly what cancels out. And you're left with 1 over 6xy, right? And you could have used the property of exponents, top minus bottom or what have you. But this is good too. Okay, so just be careful when you're canceling out factors. When you're canceling out factors, see, notice that they're factors of the product, right? They're all factored out. But here, so this case, they factored out 3 and then the 7. Here, they factored out an x minus 9. But then here, sometimes some people do this. They just say, oh, here's an x, and that does not work. So no, that's a big no-no, right? Because you wouldn't say, oh, 5 over 6, that's equal to 2 plus 3 over 2 times 3, and then go, oh yeah, this cancels, and my answer would be 3 over 3, which is equal to 1. So that's wrong, okay? So notice it can't be a sum. It has to be a product in order for you to cancel it out, okay? So let's do some rational polynomials. So we need to remember GCF and all the factoring tips and tricks that we have so far. So on the top, you can factor out a 2, and you're left with x plus 4. On the bottom, you can factor out a 5, and then you're left with x plus 4. And then the x plus 4s cancel, and you're left with 2/5. Okay, and for the next line, you can factor, what are the 2 factors of 6 that become 5? And we did that before, but that's x plus 2, x plus 3. And then in the denominator, you have, what are the factors of 12 that combine to become 8? So they're positive, so you say 2 and 6, right? So then you would get x plus 6, x plus 2, or x plus 2, x plus 6 in the denominator. But, oh, sorry, this is a 6. So then what cancels are the x plus 2s. And your final answer is x plus 3 over x plus 6. Okay, let's do the next one. What if you have difference of squares? So these are just, here, negative 42. What are the factors of negative 42 that equal to 1? So if you say 7 times negative 6, that's fine. And then that becomes y plus 7, y minus 6 on the top, and then the bottom is difference of 2 squares, so you have y plus 6, y minus 6, and then the y minus 6 cancels out, and you get y plus 7 over y plus 6. All right, and then let's do another example here. It looks like you have factoring by grouping, sorry. Factoring by grouping, how do we know that it's factoring by grouping? We know that it's because you have 4 terms here, okay? So for here, we're going to factor by grouping these terms together, okay? So for the first 2, we can factor out a p squared. That gives me p minus 2. The second 2, we can factor out a 2. That gives me p minus 2, right? On the bottom, 2 factors of negative 10 that equal to negative 7. That's negative 2 and negative 5. So you get p minus 2, p minus 5. Okay, and then finishing the top reduces to p minus 2, p squared plus 2 on the top. And on the bottom, it's p minus 2, p minus 5. So then the p minus 2's cancel out, and your final answer is p squared plus 2 all over p minus 5. Okay, alrighty. Let's do, I guess, one more. This one is a sum of cubes over difference of squares. So sum of cubes, remember what they are? So that would be m cubed plus 2 cubes. So m plus 2 times m squared plus minus the product. So that would be 2m plus the last term, the squared. So 2 squared would be 4. And then the bottom would be m plus 2, m minus 2. And then the m plus 2's cancel out. Your final answer is m squared minus 2m plus 4 all over m minus 2. And you can't factor that anymore, so that is it. Okay, so then one type of factoring we need to be okay with is opposites in a rational expression. So opposites in a rational expression. So the opposite of a minus b is b minus a. So let's try that. So 1 minus 2 is negative 1. 2 minus 1 is positive 1. Okay, so they're opposites. That's cool. So one way that you can see it, if you have an expression and it's opposite underneath, then when you divide them, the ratio of them is going to be just negative 1. Okay? So let's say here you have x minus 8 over 8 minus x. So we can just see that here this is going to be the opposite. They're opposites. In other words, x minus 8 is equal to the opposite, which is negative 8 minus x. So then you can see even this way becomes negative 1. Okay? And you might even just be able to skip that step and go straight to negative 1. If everything's the same except that the order changes and it's subtraction. So I can even show you by thinking of it this way. This is positive and this is negative, right? So what if I had factored out a negative? If I just factor out a negative, well, then I get negative x plus 8. But then if I commute the order, I get negative 8 minus x. So see, it's the same thing. So now here, all you need to do is say, oh, these are opposite. Then that's going to equal negative 1. Okay, let's use this a little bit. So 14 minus 2x LCD is going to be 2, 7 minus x. On the bottom, difference of squares, x minus 7, x plus 8. Well, I mean, I don't know why I put 8. Oh my gosh, I mean 7. Distracted. So then here, because it says these are the opposite, you can notice, then that's just going to be negative 1. So then your final answer, so these cancel out and you're left with negative 2 over x plus 7. Okay, and that's because 7 minus x over x minus 7 equals negative 1. Okay, let's try this again. The top 3y minus 9, and on the bottom you get 9 minus y, 9 plus y. So this cancels and becomes negative 1, so that's negative 3 over 9 plus y, and we're done. Okay, so that's it for 8.1. Here's your super fun homework. Good luck, happy studying, and I will see you in the next video.